Good morning and afternoon, everyone. Welcome to today's webinar, MemSQL 7.1 release. My name is Alicia and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. In today's webinar, we will showcase the latest release of our database featuring improvements to TCO, system of record support, single store, programmability, and manageability. With that said, I'd like to introduce our speaker, Eric Hansen. Eric is Director of Product Management of the MemSQL database. He is responsible for query processing, extensibility, and geospatial feature areas. He is a PhD graduate of UC Berkeley, was an Air Force officer, a professor of computer science at the University of Florida, and a principal program manager and developer for SQL Server at Microsoft. Eric was a Hive committer for contributions to Stinger and is a technology expert on data warehousing, column stores, and vectorized query execution. Thank you for joining us today and welcome, Eric. You now have the floor.
All right, thanks, Alicia. So it's my pleasure to talk to you today about the MemSQL 7.1 release, which just came out about 2.5 weeks ago. I'm going to talk today about the themes of the 7.1 release, the new features and benefits of the release, and where to learn more about it. The major themes of this release are manageability and resilience, single store, and ease of use and programmability. So the manageability and resilience features that we've added in the 7.1 release are the following: backup and restore support for Google Cloud Storage. So you can see that a theme that we have is to make sure that all of our storage related capabilities work on all the major cloud storage platforms. And the second feature in this release is incremental backup and restore for S3, GCS, and Azure. Then DR failback. DR is disaster recovery. I'll tell you more about that in a moment. Load balance failover related to when a node fails, how its work is then moved to other nodes in the cluster in a more balanced fashion than in the past. Partition split during backup. So this is a way to split partitions in a database in an offline fashion. Configurable password policy and failed login attempt security. So, and finally, there's one other feature that doesn't really fit under this category, but it's in the storage area where most of these manageability and resilience features lie. So I'll talk about that here too, which is global temporary tables. Load balanced failover is a feature that we've added in 7.1 that's a new clustering behavior in our high availability architecture. And partition replicas are spread out among about square root of n leaves, not just one paired node. So in the past, the default behavior for MemSQL has, when you turn on high availability, remember that MemSQL has a partitioned database structure. So every database is split into multiple partitions. A partition has one primary node, and if high availability is enabled, it's also on one secondary node. And it used to be that every partition from one node was going to be replicated to the same second node. So if the primary node went down, its work would fail over to that second node. And that could create a hotspot on the second node by doubling the work that it had to do to process queries and updates. So in order to reduce this hotspot effect, what we've done is, instead of replicating, all the work from one node to one other node, we spread it around, and using a heuristic, which is to spread it to about square root of n other leaf nodes, not just one, where n is the total number of leaf nodes in the cluster. The benefits of this are, again, it avoids hotspots. Also, but there is a trade-off between availability and spreading the load. So, we didn't pick, n-1 other leaves to spread out the data. That would have had the most balanced effect, but it also would have increased the probability of losing access to data if you lose 2 nodes. So as a trade-off, we picked square root of n. So this is an option now that you can choose for failover in 7.1. We've also introduced disaster recovery failback using what we call a differential approach. So it used to be that if you had disaster recovery set up where you had a primary cluster in one geographic location and a secondary cluster in a different geographic location as a disaster recovery site, then you can replicate a database from your primary to your secondary, and then if the primary goes down, you can point your applications to the secondary and make it the primary, promote it to be the primary. This existed prior to 7.1, but suppose your primary comes back again and you want to make, promote it to be the primary again and handle the workload, then prior to MemSQL 7.1, you had to copy the entire database back to the original site. And if it was a really huge database, that could take a long time and might not be suitable. So what we've now done is introduce the ability to fail back to the original site, but only copy what changed when you were updating the secondary site, and not copy everything over again. So in this diagram, you can see there's the original state where you're replicating, in a disaster recovery setup from one cluster to another. And then suppose the primary DB cluster, which contains DB1, failed. You point your applications to the secondary cluster. They run for a while and they create some changes, and that's called change set 1 in blue there on the right. Then now suppose that DB1 comes back again. You can set up replication to replicate back from DB2, which has been promoted to the primary, back to the original primary DB1, which is now the secondary. And that we've copied change set 1 over, and now change set 2 has been accumulated. At some point, you'll need to redirect the apps back to the original primary site. And so you'll have to lock out updates for a while, and there's a way to do that. And then the additional changes, change set 2 that you've accumulated, will be propagated over. When everything's the same on both sides, then you will have to take some additional steps to make DB1 the primary again and point your apps back to DB1. I'm not going to go through those detailed steps now, but this is just an illustration of how we've made the DR failback process a lot faster by using this differential approach. Next, another important management operation that people sometimes need to perform is to split partitions. So if you've had a database that has grown a lot and you've added more nodes to your cluster over a period of time, you may get to a state where you don't think you have enough partitions per node. So ultimately, you may get down to 1 partition per node and still need to add more resources, and then you're kind of stuck. Prior to MemSQL 7.1, it wasn't easy to split partitions. What you had to do is basically create a new database and take your original database down, copy all the data over to the new database, table by table with, say, insert select type queries. So it could be done, but it was pretty tedious to do. And so partition split during backup is an offline split partitions operation that basically you can take a backup of an existing database and it splits the partitions in two. So in this example, if you had a database with 4 partitions, you could do backup with split partitions and end up with a backup of your database that has 8 partitions in it, but all the same data. So once you've done this, and now you want to bring the database back online with this new twice as many partitions, what you need to do is verify the backup. This is really an optional step, but some database administrators like to wear a belt and suspenders. So, when you may want to verify your backup by restoring it to a different database name first, and make sure that the data is all there, and you're satisfied that the backup and restore process had integrity that you wanted. Then you drop the original database. Then you need to restore the backup to the original database name. The benefits of this are that it enables database or cluster expansion with more concurrency and parallelism. Another kind of a niche feature, but one that's super useful and exciting for certain types of use cases, is global temp tables. So a temp table is a in-memory only table that's not logged. It doesn't have high availability. And we already have temp tables prior to 7.1 in MemSQL, but they were local to a session. And so global temp tables are similar to the current temporary tables, or the ones that we had prior to 7.1, but they're globally visible, and they have a name that can be used on multiple sessions. So again, they're not replicated and not logged. So use caution when using these. These are for temporary scratch use. They're not for high availability. And if a leaf fails or restarts, you're going to have to drop and recreate a global temp table. It'll go into an error state, and when it's in that state, you'll have to drop it and recreate it to start using it again. They're for row store only. It doesn't really make sense to use them for column stores. You can't have a non-logged, non-persisted column store. That's just not a realistic expectation. And then they're visible in multiple sessions. So the benefits of global temp tables are extremely fast inserts, because you don't have to write to the log, you don't have to replicate data from one node to another. So you can get up to 3 times speed boost for rapid insert workloads, especially if you have slow disks. Like if you have slow magnetic disks, the speed up could be very, very noticeable. And I like to describe it as a great shock absorber, or an extract, load, transform scratch pad. So if you have like a bursty workload where you've got to blast in tens of millions or hundreds of millions of rows of data in a few minutes, and then you want to clean it up and transform it, and then do, say, insert into, select from operations to move it into another table that's persisted and has high availability turned on, whether it's a column store or not. This feature is great for that. Another manageability capability new in 7.1 is configurable password complexity policy. So there's some new global variables that let you set things like max consecutive repeat characters or sequential characters, minimum length, minimum number of lowercase, numeric, special characters, uppercase characters. So using these variables, you can set virtually any needed password complexity policy directly in the MemSQL database. So you can enforce your corporate security standards this way without the need to rely on an external system like a single sign-on system like SAML or PAM, if that's not what you want. Like a lot of our customers already use SAML or PAM to manage password logins, and those systems can set complexity policy for you. So But if you really want to do it all in the database and don't want to have another moving part in your environment, this could simplify things and make it possible to do it all with MemSQL. Many of you may have heard of single store already. We introduced some of the initial features in the single store wave in the 7.0 release. And now we've continued to add to them in 7.1. So a little bit of history about MemSQL. In 6.8 and earlier, we had what we call dual store, where we had two table types, row-oriented tables and column-oriented tables. And row-oriented tables are fantastic for transactional type workloads. And also, they're also pretty fast for analytics as well. So if you have a workload that has a lot of single row lookups and updates, and row-oriented tables are great for that. Column-oriented tables are excellent for analytical workloads, but they're not as good for those single row query and update operations because the overhead of updating one row could be significant. In 7.0, we transitioned to single store. So for row-oriented tables, we added one feature, which is sparse data compression. The problem we were trying to solve is to improve total cost of ownership for transactional workloads or workloads that are hybrid transactional and analytical workloads with a significant transactional component. We wanted to make those workloads more economical to run on MemSQL and improve total cost of ownership. So we came at from two angles. One was add sparse compression for row-oriented tables, which is good for wide tables with lots of null values. And we added the ability to do fast seeks to find an individual row with column-oriented tables, and including the ability to provide secondary hash indexes on column store tables. So in MemSQL 7.1 and continuing through the MemSQL 7.5 release, which is going to come later, dual store is continuing to become single store. So we're still going to have row-oriented tables. That sparse feature remains, but we're putting more and more energy into enhancing column-oriented tables with the ability to handle transactional workloads, as well as being a fantastic storage structure for analytical workloads. So you can do it all with one table type. So the single store, the best way to think about it is column store is evolving to become single store. So it has the ability to handle row-oriented types of work as well as analytical work. So again, in 7.0, we had these fast seeks and secondary hash indexes. Now in 7.1, we've added support for fast seeks with join queries. So if you've got a query that can benefit from, say, a nested loop type join with seeking on the index on the inner table, that is now supported in 7.1, and I'll say more about that. And then single column unique constraints were also added in 7.1. And so watch this space in 7.5. There's more coming. There's several new things coming. Like we've heard that many people want to have upsert capability work on single store. So watch this space in the future. So here's a highlight of single store performance in 7.1 that illustrates our new hybrid hash loop join strategy, which enables highly selective join queries to work really fast on column stores. So in this example, I created a orders table and line items table in a sort of a hypothetical OLTP-like environment. And each order has two line items. So you can read the schemas there on the left. There's 33 million rows in orders and 67 million rows in line items. So suppose I wanted to find a query that had all the information about one specific order. That order is a join, that query is a join query that joins orders and line items on order ID or OID. Now, and that would be a selective filter on the order table to pull out the one row that I was interested in. So I generated the data in such a way that there's only one order at a specific timestamp there. So by filtering on O.D equals that constant value, that picks out exactly one row from orders, and then it joins it to line items to get the desired result, which is two rows of output. So the runtime of that query on MemSQL 7.1 on a small cluster is 1 millisecond. So comparing that to 6.8 and 7.0 without this hybrid hash loop join feature, that took 7 milliseconds. So the way this capability works is you won't see, so you'll see a plan that has a hash join in it. The hash join itself will dynamically switch internally to use a nested loop join type strategy if there are very few rows on the what's called the build side of the hash join, where in this case the build side would be on the O side, and there would be only one row in the hash table. So the hash join will say, oh, there's an index on the L.OID table. Excuse me, and there's an index on the L table on the OID column, and there's only one row in the hash table. Therefore, I will switch my strategy and not use a hash join, but I'll use like a loop join strategy where I'll seek into the OID column on L. And if you look at the line items table on the left, you'll see it says key OID using hash. What that at the bottom, what that does is it creates a hash index on OID, and that can be used by this hybrid hash loop join. So the main take for me, it's stunning that you can get 1 millisecond response time for a query like that on column stores. So that's OLTP level performance for a selective query on column stores. And honestly, I was kind of surprised that it took only 7 milliseconds to do it in 7.0. So it was darn good on 7.0. Now it's phenomenal. Moving on to ease of use and programmability in 7.1. So SQL usability has been improved in 7.1, as well as extensibility and ingest. Regarding SQL usability, MemSQL 7.1 now fully supports case-insensitive table names. Case-insensitive table name support was actually added in 7.0.11 in an intermediate patch release, but it wasn't really completely done yet because you may want to evolve an existing database from case-insensitive table names to use. Excuse me, you may want to involve an existing database which is using case-sensitive table names, that's just the default, to a new cluster that's using case insensitivity. So what we have added in 7.1 is the ability to restore a backup of a database that was that had a different case sensitivity setting into a cluster that into a new cluster. So you could evolve your environment. You suppose you had a cluster that had one database in it, and you wanted to evolve it. You could back up the database, then drop that database from the cluster, and then change your case sensitivity setting, and then restore the database. That is now supported in 7.1. So you can evolve your environment into a different case sensitivity setting. And we've also added support for some new industry standard built-in functions that are popular in Oracle and Postgres. So the new functions that we've added are toNumber, trunc, and regex substring. So toNumber takes a character string and a format mask and converts the character string into a number based on the format mask. So it's a convenient feature that if people are used to using Oracle or Postgres and they're using toNumber and they want to migrate to MemSQL, this can enable them to do that a little bit more easily. And then trunc is another function that is popular in Oracle and Postgres that can take a you can do things like take a date and truncate it to, say, the first day of the year or the month. So it's a popular function. It can help ease migration of applications. And then regex substring is another one which allows you to take have a string value and then a regular expression, and that regular expression can define how to pick elements out of the string. So this particular use case allows you to pick the second element out of a comma separated list of numbers and then return that. So that can be a pretty powerful function for string manipulation and data transformation. Another major enhancement to enable more operational type workloads to be written more easily in MemSQL using our stored procedures is singleton select into variables in stored procedures. So we added support for select into variables. And this is the same syntax that's used in PL SQL. We now support it in our MPSQL stored procedure programming language. So the reason we did this, even though you could already handle this scenario. Now it's a common scenario that you may want to retrieve a single row from a table or the join of several tables. And then for all the columns that you retrieve, you want to assign their values into some variables. And then later in your stored procedure, you'll do something with those variables. So that's very common programming paradigm. And we could handle that before, but it took a lot of lines of code to do the same thing. Note that this also works not only with static SQL, like on the first query, but also with dynamic SQL as shown at the bottom. So the old way of doing this was pretty verbose. Prior to 7.1, you'd have to declare a query, and then declare an array, and then use the collect operation on the query and assign the results into the array, and then extract the values from the initial element of the array, which is number 0. So yeah, it could be done before, but it is several times more lines of code and more tedious to do. So this makes it a lot easier to program transaction processing style operations that are looking up one row with our stored procedures in MPSQL. Another enhancement we've made to MPSQL is the ability to access record fields and SQL statements in SP. So if you look there in the for loop towards the end, this enables you to reduce lines of code for cursor-like operations. So you can say for R in collect of a query loop, and then you'll do one trip through the loop body for each row returned. And now that in that insert statement, for example, insert T2 values R.A, R.B. R.A is the field of the record R, which is the loop iteration variable. So now you can refer directly to loop iteration record variable fields like R.A or R.B inside SQL statements inside the loop. And this reduces the number of lines of code that used to be required before. You had to assign the values of each field into a scalar variable, and then you could use the scalar variable inside the other SQL statements. So that was kind of verbose. So we've done this to make it easier to program with less lines of code in MPSQL. Moving on to ingest, we've added Google Cloud Storage support for our pipelines feature. So most of you may know that pipelines is a really kind of innovative and powerful feature for loading data into MemSQL continuously from some storage location like a file system or an S3 bucket, and now you can use it with Google Cloud Storage as the source. So we now support all major cloud storage types for pipelines, including S3, Azure, and Google Cloud Storage. All right, if you want to learn more about the 7.1 release, check out our documentation. There's an overview section in the documentation that talks about the new things in the release, and also check our blogs. So I've written blogs about the 7.1 release and also the single store capabilities in 7.1, and that you can read those to learn more about the release. They're a good summary of what's new and sort of the benefits of it and some of the technology. And then we have online training available as well. So check training.memsql.com. So I'd like to ask you to if you haven't used MemSQL, try it for free. Start today, so you can get started with MemSQL for free using either a Helios free 8-hour trial, or you can download MemSQL and get a free license that allows you to use it on up to a 4-node cluster of that's pretty good size, and it's really an amazing value when you consider what you can do with that. You could have a very impressive data mart, for example, on a free cluster with hundreds of millions or even billions of rows without the need to pay for a license. So check it out and contact team@memsql.com if you'd like to have a sales consultation. All right, so at this time, I'm ready to take questions.
Awesome. Thanks, Eric. Thanks for your presentation. We'll now begin the Q&A portion of today's webinar. I know we are a bit short on time. However, we will be answering as many questions as we can. And just a reminder, you may submit questions through the Q&A function located in the lower right side of your console. And for those that have questions that we won't have a chance to address, given the time, we will be following up with you in regards to your questions. So let's start with this question. If I don't see a nested loop join in my query plan, am I getting a hybrid hash loop join?
Yeah, that's a good question. So on row stores, if a nested loop join operation is needed, the query optimizer can pick a nested loop join and put it in the plan. And so if you look at the explain plan, you'll actually see a nested loop join operator. With single store or column store oriented hash joins, you'll just see a hash join operator. You won't see a loop join, but the hash join operator itself will switch over internally and do a nested loop join during query execution if that is a beneficial thing. So no, you won't see a nested loop join, but it will be doing a nested loop join style operation.
Great, thank you. How do I create a single store table?
So if you want to create a single store table, create a column store. So there's really no storage structure called single store, but what we're doing is we're evolving our column store to be single store. So it has the ability to handle row-oriented workloads and analytical workloads well on both on column store. So column store is becoming single store. So create a column store.
Okay. Is single store in memory?
So single store is a disk-based table type. So single stores are column stores, as I said. So column stores are stored on disk. Each column is stored separately on disk. The tables are broken up into million row chunks called segments. There's also dictionary structures that are used for column stores. The dictionaries and the column segments are stored on disk. they're cached in memory in the Linux file system buffer pool. So, so short answer is no. Single stores are not in memory only; they're disk-based. But we use memory to speed up access by caching recently accessed data in the file system buffer pool.
Thanks, Eric. Thanks everyone for all of your questions. Unfortunately, that's all the time we have for today. So for those of you with questions we didn't have a chance to address, we'll follow up with you directly. We also have a short survey followed by the close of the webinar and appreciate your participation if you can stick around for an extra minute. I want to thank Eric and each of you for attending today. Just a reminder, we'll be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, you can send us an email to team@memsql.com. Again, thanks for participating and have a great remainder of your day.